Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Muhammad Maksum and my supervisor is Madam Nur Faizah binti Aminuddin. My final year project title is Design and Analysis of Lighting System for Hydroponic Fodder using NodeMCU. For introduction, in animal husbandry, there are a variety of feeding methods for cattle, each with its own set of benefits and drawbacks. In order to improve the energy density of the feed, cattle raised in feedlot are given hay supplemented with grain, soil and other substances. In general, dairy farm only pay a little attention to fodder production and instead concentrate on providing concentrated feed to their animal, which require a significant expenditure. Green fodder has many health advantages that may assist to decrease the chance of animal getting sick. On the effort of enhancing fodder production, artificial light has been added to the system to replace the sun at night. With artificial light, fodder plant will receive light continuously and regularly. So my problem statement is the selection of suitable artificial light to replace sunlight to help rapid growth is very important. Each light emitted by artificial light has different wavelength rate. The problem will arise when artificial light emits a wavelength more or less than the value required by the plant. So for my research objective, firstly to analyze the type of light that's suitable for the crop. Second, to autonomously control the lighting system. The third one is to conduct a study about the growth rate of the fodder crop. For the scope of research, first, designing the lighting system by considering all factors including the type of light. Second, choosing the suitable color combination to enhance the plant growth rate. The third one is selection of NodeMCU component that is required by the system. The fourth one is designing an automatic lighting system for the fodder system. And the last one is observation and analysis on the grass growth and time taken with respect to the duration of plant receiving light sources. So there are three types of planting without soil. Firstly is aquaponic, second is aeroponic, and for my project, I use hydroponic system. For the type of growing light, there are several light can grow the hydroponic fodder. The first one is incandescent light, the second one is fluorescent light, the third one is high intensity discharge lamp, and the last one is light emitting diode, which is LED. So what is microcontroller? Microcontroller is a computer that has one or more CPU, memory and programmable input or output peripherals. Microcontroller in contrast to the microprocessor. The microprocessor used in personal computer and other general purpose application. The microcontroller is related to but less complex than a system on a chip, which we call it as a SoC. Mixed signal microcontroller are commonly used to operate non-digital electronic system by incorporating analog component. For low consumption, some microcontroller employ 4-bit words and run at frequency as low as 4 kHz. Basically, there are two famous microcontroller. First is Arduino and the second one is NodeMCU. For Arduino, it is a free and open source platform for building and programming electrical device. In these modern days, a circuit board like Arduino with chip can be programmed to do numerous numbers of tasks. For NodeMCU is an open source firmware for which open source prototyping board design are available. The word NodeMCU refers to the firmware rather than the development kits that go with it. In my project, I also put sensor. So sensor is a device that generates an output signal in order to detect a physical event. The usage of sensor has grown beyond the conventional discipline of temperature, pressure, flow monitoring, thanks to development in micro machinery and easy to use microcontroller platform. Anyone, everywhere, and at any time may require vital analytical information with this class of sensor, without the need for recalibration or concern about contamination. So basically, there are four components important in this project. Firstly, NodeMCU ESP8266. Second is LED strip. The third one DHT22, which is humidity sensor, and the last one is soil moisture sensor. The reason why I choose NodeMCU ESP8266 over other Arduino board is because the NodeMCU have built-in Wi-Fi. So the built-in Wi-Fi can connect to the Blink. The Blink is a IoT platform that allows users to build their own application to control and receive data from their project over the internet. So when the NodeMCU have internet connection, it will display the data on the Blink software, which allow users to track their hydroponic current condition. This is the interface of the Blink. So we can install the Blink software on Android or iOS smartphone. So this interface shows the moisture and humidity of the Fodder plant. So this is my project setup. I use 4 LED strip, the combination of red LED strip and blue LED strip. And for the housing, actually it has three floor, and for every floor I put the combination of 2 red LED strip and blue LED strip. For the NodeMCU working code, on the left is a part of the working code. So when the soil moisture sensor detect the plant in dry condition equal or above 1000, it will send analog signal to the NodeMCU to turn on the pump. So when the pump sprinkle the water, it will make the fodder become moist, become wet. So when the soil condition are wet below 1000 condition, the sensor will send another analog signal to the NodeMCU to turn off the water pump and turn on the light system. So the system working 24 hour system. So for the analysis, the first analysis I do is planting using sunlight. The height on the first day is 5.5 cm. I took every 2 days. So the average of the plant growth rate is 0.33 cm. So for the harvest height, fodder can be harvested when it reaches 30 cm. So from the 7.5 cm, from the first day, it took 80 days for this planting to reach the 30 cm height. So the second analysis, I use LED strip. So for the plant growth rate average 1.17 cm per day. So in order to reach the 30 cm, it took only 24 days. For the summary of analysis result, the graph clearly shows that the growth rate for hydroponic crops with the help of artificial light was successfully increased compared to hydroponic crops with sunlight. In addition, a reduction in time taken from 80 days to 24 days can help accelerate the production of hydroponic crops. So, the increasing of the difference between the planting using sunlight and planting using LED strip is 70%. So, as a conclusion, first of all, the selection of LED strip lamp as lamp that will provide light to the project has been successful. Subsequently, the selection of the NodeMCU as microcontroller to automatically control light also provide encouraging result. This advantage of built-in Wi-Fi is one of the reasons why NodeMCU was chosen to be a microcontroller in this project compared to Arduino. So for the recommendation for further study, I recommend to using lab that can produce larger lumens to accelerate crop growth rates. For my setup, the lumens is only 180 lumens. So second recommendation, I recommend to using sensors that are also capable reading the temperature condition. This is due to we take care for the temperature surrounding for the growth, for the plant growth. So that's all from me. Thank you very much.
Humidity pun naik kan. Humidity naik lembab kan.